Hello students, welcome to our channel Feynman Institute. Here I will be solving the 12th max exam of 2021, and here I have the first question is find the value of x, for which these two determinants are given. So the solution is given here. You can operate this determinant and equate, and you will get x squared equal to 8, and you will obtain x equal to plus or minus 2 root 2. And second question is find j from this matrix and then find a into j. So I have used a simple trick here, or you can follow the exact procedure. Here I have interchanged this 1 and 4 and add minus sign here and here. So that will be at j. And a into at j is basically the matrix multiplication of these two matrices, which will give us the answer, a diagonal matrix with diagonal elements minus 2 and minus 2. Now, so that is the answer for part 1 and part 2 of question 2. And the third question is find the value of k such that this function is continuous at x equal to 5. So here I have shown that this is the condition for continuity of the function at x is equal to 5. So the limit should be equal to the value of the function at that point. And if we equate, we will get the limit at this point for x less than 5 should be equal to the value of the function at x is equal to 5. So substituting this, we will get this expression. Non solving, you will get substitute x is equal to 5 here, and solving this simple equation, we can obtain the value as k equal to 9 by 5. So that's the solution for the third question. Now, the fourth question was to verify Rolle's theorem for this function in this interval. So this question is already solved in the textbook. So please refer to the textbook exercise number 5.8, the first question. Now, the fifth question is find the rate of change of area of a circle with respect to the radius with r is equal to 5 centimeter. So area of circle is a equal to pi r squared. So the rate of change of area with respect to radius r is dA by dr. And so take a derivative of this function. So here area is a function of r. Take a derivative with respect to r. You get this expression a equal to dA by dr equal to 2 pi r. And now substitute the value r equal to 5 centimeter, and you will get the exact rate of change of area with respect to radius, which is numerically equal to 3 pi centimeters. Now, sixth question, projection of this vector into the vector b. So we have two vectors, we have to find the projection. So this is a direct question, you can apply the direct formula or use some graphical techniques. So here I have marked a and b vector, and the projection of a vector on b is the perpendicular line or projection to the b, which is basically a cos theta. So you take the dot product a dot b, which would be 60, and projection will be a cos theta, which would be a dot b by modulus of b vector. So that is basically 60 by modulus of b. Here this is a b vector. Modulus of b means root of bx square plus by square plus bz square, which would give us the value 60 by square root of 114. So that's the answer. Now seventh question we have already done. Now let's move on to the eighth question. So which of the following can be the domain of function cos inverse x? So here some confusion is there. Actually this question has an error, because actually this should be a range. Instead of domain, they should have asked what is the range of cos inverse x, because the domain of cos inverse x function is -1 to 1, right? And the range is 0 to pi, right? So like there is an error in the question paper, and if the question was what was the range of cos inverse x, then answer would be 0 to pi. Now the second part of 8th question, find the value of cos inverse -1 by 2 plus 2 sin inverse 1 by 2. So to sin inverse 1 by 2, you know the value, it's 30 degree or pi by 6. Sin inverse 1 minus 1 by 2 is pi minus sin inverse 1 by 2, right? So cos inverse minus 1 by 2 is pi minus cos inverse 1 by 2, and this value you know pi by 3. Substitute it, you will get the value pi. Now, okay, find the area of a triangle given this vertices. So you can simply find the area using this formula directly. Area is equal to half into determinant of this value. Substitute these coordinates here and take the determinant, and you will get the area, which would be numerically equal to minus 7.5 square unit. Now the last question of part A, which was find the general solution of this differential equation. So I think this question was out of your focus area. Still, I will explain this answer. So this is a simple question. This equation is a first order linear ordinary differential equation. So the solution of a first order linear ordinary differential equation is you have to find the integrating factor. This is the general form of a first order linear ordinary differential equation. We have p of x and q of x here. So here p of x is minus 1 and q of x is cos x. And find the integrating factor, which is nothing but e to the power integral p dx. So p is a function of x. Here it is a constant minus 1. Substitute here, integrate it, you will get the integrating factor e to the power minus 6. Now to find the solution, you have to use this formula, that is y into integrating factor equal to integral of q of x into integrating factor dx. So q of x is cos x and integrating factor is e raised to minus x dx. You can have to simply integrate this, then you will get the general solution. So this integral you have already studied and you have done it in the integral chapter, but I'll still explain this integral. So this is a simple integral. Use the integration by parts method. So using by parts, cos x is the first function, this is the second function. Integrate it, you will get another integral, and that integral I label it as I2, and I evaluated I2 again using by parts again, and which is first function into integral second function minus integral derivative of first function into integral second function dx. So once you integrate it, you will get back the first integral, which is I again. So you solve this equation, you will get 2i equal to sin x minus cos x into e to the power minus x, and from that you will get the value of I, which is sin x minus cos x by 2 e to the power minus x. This question is already done in the integrals chapter and you already know. And now our aim was to find the general solution of this first order linear differential equation. So you have to substitute this integral here and you will get the pi of x, which is the solution of this linear differential equation. So I substitute the value here and I slightly rearranged it. So we get y of x is equal to sin x minus cos x by 2 plus c into e raised to x. So this is the general solution of this linear differential equation. So that's all for now. Please subscribe the channel. Okay, this is the part 1 of this video. I will probably upload the part 2 a little time later. So thank you for watching this video. Subscribe the channel and good luck for your next exam.